Hello, everyone. I hope you had a wonderful day today. Right, we are meeting again in order to look at the rest of this chapter, which is on loci. Yesterday, we started with mechanisms. We looked at the terminology. I'm just going to recap so that we link with what we did yesterday. Right, so we talked about issues like a linked crank, constrained, revolves, pivoted, swing, sliding, and so forth. Right, some of these terms would make sense when we actually look at the scenario that we are going to face. So I'm not going to spend a lot of time explaining these. This is a practical subject. We need to also to look at the actual application in order for us to be able to understand what we are doing. So let's get straight to it. Today we are going basically to look at the application exercises with regards to mechanisms. Right, so we still have got our loci, right, which is the plural for locus. Right, some would call it loci, right, it doesn't matter. The meaning would remain the same. Right, so mechanisms, we are looking at construction and application exercises on mechanisms. This would lead us to this very good statement of ours. I hear and I forget, I see and I remember, I do and I understand. So I want you to pay attention so that you'll be able to do it on your own. The application part is the one which is key in EGD. So I want each and every one of you to be independent. You can only be independent if you know what you are doing, and that understanding can only come as a result of your experience, your past experience in doing something similar to what you are supposed to be doing right now. So enjoy the rest of the lesson and good luck. Right, this is where we are today. Right, we have got the given information which is follows. A linked crank mechanism consisting of a crank AB. You have got A to B, that is the crank AB, which is attached to a connecting rod BC. You have got B to C. Right, and you are given this in form of a schematic diagram of the mechanism. Right, remember yesterday I explained quite a bit with regards to what it is that we refer to as schematic. Schematic basically means it's a line drawing. You disregard the thickness of components, you simply represent the line in terms of the center of the components, and then we refer to that one as a schematic diagram. Right, motion. As crank AB rotates in a clockwise direction, so you have got AB, which is rotating in a clockwise direction, right? C moves to and from along axis DD, right? We have got point C, which is here, right? It can only move along the axis DD. Right, therefore we can as well say that C is constrained to slide along, right? Those are some of the terms that you can find or that you can meet in other literature with regards to the same description. Draw to scale 1:1 the given schematic diagram of the mechanism. Right, so we have got this. We want to draw it here in terms of copying. With a scale 1:1, trace the locus generated by point P. Point P is somewhere here, right? So as the crank is moving, you'd find that naturally point P would also change position. So by changing position, it creates a path. That path is what we refer to as the locus of point P. For one complete revolution of the mechanism, show all necessary constructions. So what we need to do at this point, we can draw, right, a faint line like that. Bring this one to, and another faint line like that. Right, we are given the diameter, it's 112, that is the diameter, so that the radius, 112 divided by 2, but we are going to get 56 as our radius. To measure your 56. Take your compass right through that point, which is the 56 mark. Then you describe, right? You look at how it has been presented. You also do the same, right? As you can see, there you go. It's in form of a center line, right? Now, we now have got the locus of point B, right? By drawing this, we have already defined the locus of point B. The next thing that we want to find is, right, is to simply copy this. Now, we have got point B, which is here. I'm going to label this one. That's our point B, all right? Then we take 112 rather, which is the distance from here to there, right? Which is basically the diameter from here to there. So you can take this. You mark. Like that. So we have got our point here, right? Of course, you can still measure from here to there. Right? This one, let me just correct this. This is 100, this is 110, this is 112. All right, so this one is not required there. Let me just push this one slightly. Right. So 112. Just adjust. Okay. So the distance from this point to that, which is from here to there, you measure from here to there, right? But of course, I have already taken the distance in terms of from here to there, which should be shifted to that one. So I'm going to change that and label this one point C, okay? Point C is the distance from here to there, which is 100, 110, and 112. Okay, then connect this one to them. Connect this one to them like that. Okay, so from here to there, that's 112. Let me just verify. Sometimes you forget that the screen is outside. Right, okay. Right, so from here to there, that's 112, right? Then we can outline. I'm going to outline this. Use a much bigger set screen. First of all, we want to get point P, right, which is an extension going backwards like that. And that is 32 millimeters. And I mark with this. That is point P. There you go. Right. Then you have got P to C. P to C. I can now outline from here all the way to there. There you go. Right. When you are copying, make sure you copy everything the way it is given. Right. Okay. Then from there, you have got AB, which is here. There you go. Right, so the next thing that you would want to do, right, is to define the center line. The center line, which would also give us the axis for DD. Make sure. But let me just extend this in case. Right, like that. Then you also have got the vertical center line. Right, don't take any information which is given for granted except dimensioning. Dimensioning is not critical in terms of copying, okay? But otherwise, everything else should be copied the way it has been drawn. Like I said, this is our locus for point B, which is in form of a circle. Right, so the next thing that we want to do is to divide the circle into 12 equal parts. There you go. Right. So this is our point 0, right? We can say this is B or B0, right? You can also define the direction of rotation by indicating with an arrow. Since it is said to be clockwise, which means the movement is like that. You can show it there on the locus of point B, okay? Right, so this is point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and back to 0 like that. Right, so the next thing that you would need to consider is, right, let's suppose point B has shifted from here to there. Where would be point C? Okay, so you take the distance between B and C, right? You open it like that, right? You are going to stand at B1 and describe an arc like that. You can label this is C1. Right, like this. Right, so you take the distance between B and C like that. You stand at point 1, you describe an arc like that. You get this point. Right, this is the new position of point C. right? You go to number 2, right? What it means is that this is slightly smaller, but let me extend this one further. Right, go to point 2 and describe an arc, right? That's C2, okay? You go to point number 3, describe an arc, that's C3. You go to number 4, right? That's C4. Number 5, C5. That's C6, but which is the same as C7, C8, C9, then C10, which is the same as 8, right? That's C11, like that. So you now have got the other positions or the alternative positions of point C as the crank rotates in a clockwise direction. But the other thing that we did not define, we also can come here and show this. Right, like that. You can show it nicely with an arrowhead if it is not clear. Like that. This shows that point C can only move along this axis, which is D. So I'm going to label here, that's D, and also there, that's also D. Right, so the only motion which can be made in terms of movement of point C, it's along DD. So there's D and that there's also D there. Right, okay. Then the other thing that we now want to do, right, we now want to draw a line from point B1 to C1 and extend it backwards. So like this. Like that. Then we go to C2 and B2. Like that. Then C3 and B3, it's already there. And C2, C4 and B4. Like that. C5 and B5. Then C6 and B6. Extend backwards, we shall use that. C7 and B7. C8 and B8, C9 and B9. Let me just extend this one slightly. But then C10, like that. Then C11 and B11. Like that. Right. So we have got lines which are coming from the points, right, on the circle, right, as well as point C along the axis DD, okay? Right, once you have done that, you take now B to P, right, which is this distance. You take it like this. Remember, this is our first point, so we can actually say this is P, right, or 0. Right, we go to point 1, right, we mark, this is B1, now to P1. Then we go to point 2, you mark, this is P2. You go to point 3, that's P3. You go into point 4, that's P4. Point 5, that's P5. You do the same. 6, 7, 8, 9, 10, and 11, back to the starting position, which is that. Right. This is the path which is followed by the movement of point P, right, as crank AB rotates in a clockwise direction. So you have got this point, which is the start. You come here, right, you have that, you have that, you have that, this one. These are the points, just defining them much clearer, like that. I can join this. There you go. Right. So that is the path which is followed by point P as the crank is moving about point A, right, with the locus created like that, which is a proper circle. Right, you can now outline this. Right, there you go. Right, so that is the locus of point P. So we have got P1, P2, P3, P4, P5, P6, 7, 8, 9, 10. Can just right highlight. Right, so P, P1, right, P6, P10, like that. That is the movement of point P, and we refer to this one as the locus of point P. So if you don't take this path into consideration in terms of design of your machine or your system, you would find that certain paths may end up colliding against each other because they cut across each other's path. Right. So it is important to make sure that you are able to define the full extent of the movement of each and every part before you join everything. Otherwise, everything might end up crashing. Thank you. That was our first exercise with regards to application of mechanisms, right? Given the information and applying it to come up with the locus of a point. But we want now to look at a second scenario in terms of the exercise. So just a moment as I change the paper. We have got something like this. Right, okay. The given information, a linked crank mechanism consisting of a crank AB, which is attached to a connecting rod, which is BC. So you have got B to C, right, which is there. Right. A schematic diagram of the mechanism. This is already a schematic diagram. So we are not going to change anything. Right, as crank A, B rotates in a clockwise direction, C moves to and from along the axis DD. Right, so we have got D, D, right, C would reciprocate, that's another term, moving to and from, okay, in a straight line. Right, if it is oscillating, it's moving to and from, but in a circular manner, okay? Right, so here C is reciprocating along DD. What it means basically, it is moving to and from. Right, okay. Draw to scale 1:1 the given schematic diagram of the mechanism. Trace the locus generated by point P1 and P2. We have got P1 and P2. As the crank rotates in a clockwise direction, right, for one complete revolution of the mechanism, show on its constructions. Right, we are not going to look at a marked change from what we did with an earlier exercise. Right, again, let's start by drawing faint construction lines, horizontal line like that, and a faint vertical line like that. Right, okay, we look at the diameter in terms of the circle, which means the radius A to B is equal to 50. Scale, we are asked to use 1:1, right? So the radius is 50, so we measure 50 here. Like that. Take your canvas. Take your canvas. Just a moment. Right, okay. So you take your canvas, you stand here and there, right? You open your canvas to that convenient radius, which is 50 as your radius. You represent that circle in form of a center line. The way it is drawn, there you go, okay? So you have got a perfect circle, right? That is a representative of the locus, which is followed by point B. So you can come and label here, that is our point B. Right, we are also given that the distance from here to there is 140, right? So we are going to measure 140. Like that, that is our point C. Then you label there, that's point C, right? And also point C is connected to point B, right? Like that, right? Then you have got B to P1, that's 50. Then P1 to P2, that's 50. Let's just check. Right, let's just check. Right, we check from here to there. Right, sorry about the disturbances. Right, that's 50. Right, that's 50, which is fine. Right, so we are going to measure from here to there, 50. That's P1. Then another 50. That's P2. Okay. Right, we label this one P2, P1, right? And we can outline this. Right, so we take from here to there, that's 50. Then also from here to there, that's 50. Then we have got that distance. What we can do now, we can define the center line. But remember, this center line would continue all the way as the axis DD, okay? Right, so we make it slightly longer. Right, okay. Right, so we have got the center line from here to there, and also the center line, which is also part of the axis line. Right, like that. Right, okay. So we have got now the axis, which is basically the center line. The next thing that you want to do, you divide the circle into 12 equal parts. Like that. There you go. Right. You can also define the movement in terms of point C. Right. You can show. Like that. So we now have got, since this is moving in a clockwise direction, this will be our point B1, B2, B3, B4, and so forth. So I'm going to say this is B3, this is B6, B9, 10, 11, and back to 0 like that. Right. Then we also need to highlight this is D and D as the axis where point C would slide along. Right. Once you have done that, you can now shift the position of point B from the starting position to B1, right? And take the distance B to C and strike on that axis line. Right. So let's take the length of BC. BC, that's fine. Right. You come and stand here. And you describe an arc, you cut that, you now have got C, you now have got C1, C2, C3, that's C4, C5, C6, C7, C8, 9, That's C10. And C11. Right, back to the starting position, which is C1 like that, okay? Right, which is point C0, because C1 is here, C2, C3, C4, C5, C6, 7, 8, 9, 10, 11, back to 0. Right, the next thing that we want to do, we connect B, right, we connect B to B1 to C1. Like that. Then C3 and B3 is already there, so we go to 4. And then we go to 5. Go to 6. Seven. Right. B9, C9 is already there. We don't need to do anything. Right. Then we go to B9, C10. Like that. And then B11, C11, like that. Now you have got all the constructions that you require. Then the next thing is to take the distance P1 back to point B, okay, like this. Right, so that's B, P1, right? You stand at the new position of point P, right? You strike, that's our P1, right? P1, 1, like that. Then you stand here, that's P1, 2, stand here. That's P1, 3, go to number 4, P1, 4, P1, 5, P1, 6, P1, 7, P1, 8, then obviously this will be P1, 9, which is the same radius. The distance from here to there is the same as that one. And then from there, we now have got P1, 10, P1, 10, P1, 11. Once you have done that, you can just ascertain the points. Is this point, is that point, is that point, is that point, that one, this one, and that one too, yeah, there, and to point P, which is the starting point. You connect these points faintly. Right, faintly. Like that. So that is the path which is followed by point P. Right. Now we can outline this. We can outline this. There you go. Right. That is locus P1. Right. So I can come here, provide a leader line, show by way of an arrowhead like that, and turn this like that. Indicate nicely locus P1 like that. Right. So that is the path which is followed by point P1 as the crank AB revolves about point A for one complete revolution. Now, the next thing that we want to look at now is the path which is followed by P2. P2, right? It's either you can make use of the points that you have generated for point P1, or you can start again from point B so that we don't have a cumulative error, right? You go to point 1, which is B1, you mark again. That would be, right, P21, right? You have got this. That's P2, 2. Then you have got this. Mark. That's P2, 3. P2, 4. P2, 5. Six. Let me just verify. That's P2, 9. 10 and 11 like that. Right, then we come back to our P2, which is the original position. We can connect these points, right? That's 11, that's 10, that's 9, 8, 7, right? 6, and 5, 5, then 4, 3, 2, 1, back to 0. Right, let's connect this. There you go. The next thing that we need to do is now to outline. But we can outline with a different color. There you go. Right, remember, even if you stop somewhere in the middle, right, the curve should remain smooth and presentable. Right, then we can also level this one. Let's do it at the top or at an angle like this. Like that. Then we can label, that's locus P2. Right, so that is the path which is followed by point P2 as it completes one, as the crank or the mechanism completes one revolution like that in a clockwise direction. Right, the other thing that we did not define, which needs to be defined, right, is the issue of the direction. Okay. All right, you can show it here, or you can also show it like this. It will be still fine, right, on the outside like that. Then you define that. As long as the direction is indicated, and then you will be marked correct. Right, so that's the path which is followed by point P1. That's also the path which is followed by point P2. Right, you copy the given information as it is given, except for the dimensions. Right, where there are labels, you put those labels as well. Then you come up with an answer like that. Boys and girls, I hope you understood what we did today in terms of our lesson. And when we meet, hopefully tomorrow, we are going to have a look at some of the exercises that we get from the past exam papers so that you should also be able to tackle those ones. Right, it will be ideal for you to find an exercise, or I will give you tomorrow so that you will be able to apply the concepts that we have looked at today and as well as from yesterday, so that you on your own should be able to do this. You need independence in terms of application of these concepts, right? That would show understanding. Thank you. Enjoy the rest of your evening and good night.